This video is going to include some thoughts and some ideas and a whole bunch of facts about physical and chemical properties. So first of all, think back to what you've learned so far in chemistry. Talked about matter and the kinds of matter broken down into pure substances or mixtures. Those two things can be subdivided into different categories. A pure substance could be an element or a compound, and a mixture could be homogeneous or heterogeneous. Those qualities are not enough to describe all different kinds of matter. We have to have other things that we can use to distinguish between different things. Let's start first by talking about physical properties. As you can see on the slide, physical property is a quality of a substance that you can observe or measure without changing the composition of the substance. That's going to be really important when we get into the particulars. Without changing the composition of the substance. I'm going to give you a bunch of keywords that we're going to list that will describe different physical properties. And I think they're going to make a lot of sense. So, color. If you observe that a substance is white, or blue, or green, to make that observation, you don't change the composition of the substance, just an observation. If you test whether a substance is soluble, solubility in water, for example, then you might think, oh, that's going to change the substance, but it doesn't. If you put a sample of table salt into a container of water and it dissolves, it may look different, but the quality of the salt is the same both before and in the solution. And think about this. If you were to boil that water off out of the beaker, get the water gone, either slowly by evaporation or quickly by boiling, that salt would be there inside that beaker when you're done. So the salt hasn't changed, therefore the substance hasn't changed, its composition. So physical property would be solubility. If I said to you, substance X dissolves in water, substance Y does not dissolve in water, those physical properties describe those substances, and you don't change the composition. Maybe its looks, but not its composition. Odor. You say that a substance has no odor, or it has a very pungent odor, or it smells sweet, or it smells whatever. Those are all descriptions that don't change the substance to make the observation. If you take that sample and you put it on a scale and figure out its mass, to measure the mass of a substance, you don't change the composition, so it's physical. If you want to describe if something is hard or soft, so hardness, different metals have different softnesses and hardnesses. For example, chromium and iron are considered to be hard, but copper and gold and sodium are quite soft. So hardness is a physical property. To test it, you might hit it with a hammer, but you're not going to change the composition. Density. Density is a good one. We'll discuss that again in a few minutes. But density is a description, basically, of the substance's mass divided by its volume. So if I give you the density of a substance and I say, for example, water has a mass of 1 gram per 1 cubic centimeter, to make that observation of both its volume and its mass, you're not changing anything but the quality of water. If you talk about the substance being magnetic or having magnetism, you can test the substance with a magnet to see if it's magnetic, but you're not going to change the substance with the magnet. It's going to be either magnetic or not, but it's not going to change. Electrical conductivity. So a substance will conduct or it won't conduct. If you test it, it's the same before and after. Put a piece of copper to a current. Before and after, the copper is still copper. So it's a physical property. Melting point and boiling point. You want to test the temperature at which a substance melts. You're not changing the substance from, say, copper into lead, which is impossible. All you're doing is melting the substance. That's a physical thing. So there's nothing that's changed to the identity of the of the atoms inside. It's just a physical property. Boiling point's the same. If you want to boil something, at what temperature that it boils, to do that, you're going to change the substance from a liquid to a vapor, but you're not changing the identity of the substance. State is another very common physical property. When you describe the state of something, you're describing it as a solid or a liquid or a gas, but you're not changing the composition or anything to make that observation. A couple of new words you may not know. Malleability, or something's malleable. If a substance is malleable, that means it can be bended or like pushed into a sheet. So take, for example, aluminum. Aluminum is very malleable. You can pound that into a very thin sheet. That's a physical property. Ductile or ductility. That is another new word likely. That means it can be pulled into a wire. So copper is very ductile. You can pull copper into a wire, but you can't pull all metals into wires. That is a distinct feature of certain substances. Luster is a fancy word to describe if a substance is shiny or not shiny. So copper is quite lustrous. Other metals are more dull, which makes them not lustrous. Viscosity is a nice word. And viscosity describes basically how thick something is. So maple syrup, for example, is more viscous than water. Or molasses is more viscous than water. So viscosity would be basically in chemistry language, it's resistance to flow. If it has a higher resistance to flow, it's thicker. If it has a lower resistance to flow, it's thinner. Another word, volatility or volatile. If a metal is very volatile, not a metal, pardon me, but a liquid, let's just say, then it will evaporate very quickly. It's not spelled right. Pardon the spelling. Volatility. That means basically how quickly something will evaporate or go from a liquid to a gas. So think about a life example. Take a little alcohol swab, rub it on your arm after you've had a vaccination. That alcohol will dissolve or evaporate quite quickly, and therefore it's a physical property of alcohol to be considered to be volatile. Let's return, for example, to, we talked about before, we talked a little bit about this one with sodium metal and how sodium as a metal reacts with chlorine gas to produce sodium chloride. So, for example, sodium chloride, if I asked you to describe some physical properties of sodium chloride, what you know of is typically table salt. You might say to me that it's white. You might say that it's a solid. You might describe that it's crystalline, that it seems to be kind of like little crystals when you see it. You might say that it's soluble in water, because you know that you put it into water, it'll dissolve. Those are physical properties. Maybe you want to research and look up the melting point, for example. You'd be surprised the melting point of table salt is a lot higher than you would expect. It's 801 degrees Celsius. When you put table salt onto your French fries and it disappears if it's really hot, it doesn't actually melt. It dissolves in the steam or dissolves in the water in the fry. It doesn't technically melt. Melting is when it goes from a liquid to a gas. This is dissolving process. So, density. I could describe the density. It wouldn't really make much difference, but for example, the density of table salt is 2.17 grams per cubic centimeter. If I was to describe sodium and chlorine, I could say, for example, that sodium is a silvery metal. That would be a physical property. Silver, silver-ish in terms of a color. It's a solid. We knew that from the state above. You might say it has a melting point. That actually melts at 98 degrees Celsius. Much lower melting point. In terms of chlorine, it's a yellowish gas. Different physical property. Its color. And maybe its melting point would be of interest. It actually melts. It turns from a solid to a liquid at negative 101 degrees Celsius. These are all physical properties that describe a very common compound that we know, sodium chloride, and the elements from which it's formed. Note that the physical properties of a compound are quite often, and most often, very, very different from the elements from which it was formed. Let's contrast physical properties with chemical properties. So a chemical property is basically how a substance changes in composition or how it interacts with other substances. How a substance changes in composition or how it interacts with other substances. The thing about chemical properties that's unique, these properties are only observed when a substance is undergoing a change in composition. You can't actually tell a chemical property of a substance unless you test it to see if it will undergo a change. That'll make more sense when I give you an example. So for example, if you want to know about a chemical property, will a substance burn? Well, if you want to know, for example, a piece of paper is going to burn, you've got to light it up. So you say, oh yeah, that paper will burn after you test it. But the fact that you've tried it is going to change the composition from paper into soot. So think about that. If you want to test the chemical property of some substance, you're going to have to risk changing that substance to something else, which could very much destroy it. So if you want to know if a substance is going to decompose when you heat it, will something decompose when heated? Well, the only way you're going to know if it's going to decompose if you heat it is if you actually heat it and test it. It'll be a yes or no, but it's going to be a bad situation if you didn't actually want it to break down. Will a substance react? Will it react with water? Will it react with acid? Will it react with oxygen? The only way you can test that again is to expose your substance to acid or to oxygen or to water and see what happens. So it's very important you think about that if you want to test, so to speak, or decide a chemical property of something. You're going to have to risk losing it. Think about these words. If you want to know if a substance has a tendency to corrode or to tarnish or to explode, well, those are all very what is the word? Rigorous, I guess, and often dangerous too to test these. Something's going to explode. Take, for example, gold. If you want to know the likelihood that gold is going to corrode, you'd have to expose it to something that would make that happen if it could. For example, gold with copper. Well, copper, in fact, will corrode when it's exposed to air, especially air that has water or salt in it. But gold will not corrode. And the only way you would know that would be to expose it test it and see what happens. This will corrode, but gold will not corrode. So physical properties, when you make those judgment calls, nothing happens to the composition. But for a chemical property, to make that call, will it corrode? Will it decompose? Will it burn? You could very well change your substance. So after copper corrodes, it's turned into a new substance. In fact, it turns green. And you can think about the places where you've seen some buildings, for example, that had roofs that were originally copper, and they turn into that green, shiny patina because the copper has oxidized in the air to a copper oxygen compound. There's quite often a distinction made between intensive and extensive properties. It's like physical properties and even chemical can be subdivided between these two qualifications. So extensive properties are those where when you make that observation about a substance, you have to measure the amount of the material in a sample to give you your answer. So the amount's going to matter. So an example of an extensive property would be if you were to measure the mass. Say that a sample had 8 grams. That amount is important to give the mass. If you were going to measure the volume of a substance. So the volume, say you had 1 liter or 1,000 milliliters. To measure that property, you'd have to measure the amount. And say the length. The length of a piece of copper wire, for example. And you described it to be 15.2 centimeters. Those 3 observations all take into consideration the amount of your sample. Contrast that with intensive properties. And all these properties are independent of the amount. So let's take some examples. And I have a little expression I want you to get into your head. So if you want to describe the color, as an example, you had a sample of table salt in front of you. It would not matter if you had a tablespoon of table salt or a truckload of table salt. The color would be the same. So that's an intensive property. It doesn't matter how much you have. You can make the call about the color independent of the amount. If you want to describe the melting point, for example, if you had table salt, if you had a teaspoon or a truckload again, and you put that onto a respected some kind of a heating device that could hold the quantity you were talking about, it would melt at the same temperature, regardless if it was a small amount or a bigger amount. It's going to still melt at 801 degrees Celsius for sodium chloride. Boiling point. The boiling point as an example. So if you have a sample of water, a small little sample, or you have a large, doesn't matter if it's a pot or a teaspoon, it's going to boil at 100 degrees. Now density is the last one I'm going to talk about. In particular, there's lots. But density is something we should elaborate on. This picture comes from your booklet, and you can see that there's 4 blocks. They're all exactly the same volume. 1 centimeter by 1 centimeter by 1 centimeter, which is 1 cubic centimeter in size. That's a volume. All the volumes are the same. Note that as you go across from left to right, the mass of these substances increases. The mass of 1 cubic centimeter of ice is 0.917 grams. The mass of 1 cubic centimeter of water is 1 gram. Lead is 11.3. Osmium is 22.5. If we had the same sized block and we had, instead of those substances, we had one that was gold, the density of gold is in fact 19.3 grams per cubic centimeter. So what I want you to understand about this is that this is really important. if you had a block like this, it was 1 centimeter, so about the size of your fingernail, small fingernail, by 1 centimeter by 1 centimeter, small little cube. Or if you had a box that was 10 centimeters by 10 centimeters by 10 centimeters, so much, much bigger. And I can't draw that to scale on the slide to have it be anywhere near the size and shape of 10 centimeters bigger than the first one. But if it was 10 by 10 by 10, that would be the equivalent of 100 cubic centimeters. So think about that. You had a very small little block, 1 cubic centimeter, versus a larger block that was 10 by 10 by 10. That's 1,000 cubic centimeters. So 19.3 grams for 1 cubic centimeter. If I had 1,000 cubic centimeters for a sample of gold, it would be 1,000 times heavier. So 19,300 grams. You did the math and you divided it, you go right back to the original. Because this amount is the same, because if the block gets bigger, the sample will get heavier by the same proportional amount. This is what we call an intensive property. It doesn't matter how big your sample is, the ratio of the mass per volume is going to be the same for that sample of gold, because gold is gold. It's always equal to gold. So it's an intensive property because the mass divided by the volume for any sample size will always come down to a constant ratio. Density is an intensive property. In your booklet there are 2 other tables you may choose to look at in terms of information. They're quite helpful, quite useful. You can see that in the top table in your booklet there's intensive properties. I think I've listed all those already anyway. I don't think I listed slipperiness as a property, but it's listed on this table. Some chemical ones, a little more descriptive than mine. Decomposes when heated, tarnishes, reacts with certain metals, reacts with certain nonmetals, is toxic. So for example, you're not going to be able to test if something is toxic to humans or to dogs or to whatever. They're actually testing it. That's why it's a chemical property, not physical. The bottom table lists some properties, both physical and chemical, of some common substances. Aluminum, first on the table, it's a solid, melts at 660. The color is silvery, it's a good conductor. In terms of chemical properties, aluminum reacts with certain acids to produce hydrogen gas. Talked about table salt already. Sugar looks kind of similar to table salt. It's a solid, it's white. It melts much lower, however, and it does not conduct, whereas sodium chloride will conduct. Put it in water, and so on. The table has some good information. Next, let's talk a little bit about a common substance, sulfur. Sulfur is, as you can see in this picture, sulfur is a yellow solid. It's brittle, and if you were to hit that sample of sulfur with a hammer, it would crumble very easily. If you were to take the sample of sulfur and apply electricity to it, it would not conduct electricity. Put this sample of sulfur in water, it's not soluble in water. Okay, those are some examples of some physical properties. If you were to burn that sample of sulfur in oxygen, it would make a really stinky gas called sulfur dioxide, and it would smell kind of similar to burning matches. If you took that carbon, or this sample of sulfur rather, and mixed it in with some carbon, heated it up, you could make a liquid called carbon disulfide. That's a chemical property. Sulfur reacts with carbon to make carbon disulfide. If you put this sulfur together with a sample of iron, some iron filings, and you heated it up, you could get these individual elements to react together to make a compound called iron sulfide. That's another example of a chemical property. It reacts with iron. It reacts with carbon. It reacts with oxygen. Notice those key words are, if you want to test it, you're going to have to apply a flame or apply heat. And when you do, it's going to change from its yellow distinct properties to something different. And that's a good example of a chemical property. And last but not least, we'll do a little example of a few questions about water. So here's a couple questions. Classify the following as a physical property or a chemical property. A. Water appears colorless and odorless at 20 degrees Celsius. What do you think? Colorless and odorless? In my mind, that would be a physical property. You're not going to change it by looking at its color. Water dissolves sugar crystals. Well, if you let those sugar crystals form back again after the water evaporates, the sugar is the same, the water is the same. That's a physical property. Water produces a gas with calcium metal. You want to test if calcium metal is going to react in water, you've got to put them together. And all of a sudden now, you have a gas being produced. That's going to be an indication that something is changing, which we'll discuss in a lot of detail in the next section on physical and chemical changes. So that's a chemical property. It's changed its identity if it's going to react with a gas, or to produce a gas rather. And water exists as ice at -10. You put that water into a freezer, and you see that it freezes, that it's frozen at -10. That's a physical property, not a chemical one. And one more little set of questions to consider. If you touched a candle to a hydrogen soap bubble and it gives an explosion, let's leave these questions actually until we do physical and chemical changes. These are premature questions, so we haven't talked about this concept yet. We'll bring this up in the next video. So physical chemical properties. Physical you can observe without changing the substance. Chemical you can only observe during a change or after a change. And this is concepts going to relate very, very closely to physical and chemical changes, of course. Let's do those next and discuss what's going to happen for each of those. A couple of verbal questions before I sign off. If you said that copper is going to melt at 1083 degrees Celsius, would that be physical or chemical property? Melting doesn't change the composition, so it's physical. If you said copper has a density of 8.92 grams per milliliter, density again does not get changed by sample size, so it's physical and it's also intensive. The fact that copper conducts electricity is also a physical property. And copper turns black when heated. That's going to be an indication of something else we'll learn about in the next video.